Hi there, my name is Jay with ServerMatter, and the purpose of this video is to teach our server administration staff and our future employees how the vital statistics segment of our server was created, because it turns out to be a pretty complex animal. It's been a month and a half of effort to get it. The end result is behind me. I'm going to go ahead and lower myself. Okay, so this dashboard is the dashboard of my dreams. I want to introduce you to Grafana on a little deeper level. It's important that you understand how valuable a resource we have here that nobody else really has. This was a blank screen. It's a blank painter's canvas. There was nothing on it. Grafana doesn't supply us any of this information. It all had to be painstakingly built over time. To give you an example, I'm going to delete some of these so you have an appreciation for where we start. Grafana can be used for all kinds of things. You can find out information on the stock market. You can find how your car is running. There's all kinds of different things you can use this software for. In our case, we're using it for server metrics, and I'm not going to delete them all out, but you get the idea. We can very quickly get to a blank canvas, which is where I started this process out. We're going to reload this because I didn't save any of those changes. And these are called panels, and within each one of these panels are the metrics of building it. So if I go into the CPU load, we first see that we've used a plugin called Infinity, which is the plugin we use to read JSON data directly from the server. We use Grafana to say we want to use a gauge for the kind of display, and then there are quite a few other settings. So we've got the data source, we've got the style. We can go down here. We do have a threshold that says if it's over 80, then we want you to paint this thing red. So if that CPU load were over 80%, it would turn red. We would have a reason to pay more attention to it. Right now, it's no big deal. Some of these are much more complex than that. If we go down to this, this thing that reads the drive metrics, it also pulls its data through Infinity and through a JSON file on the server. It uses a transformation to order what goes where. For instance, we have the state as the first column right here. If I change the state, move it further down, you can see it's repositioned in the order of things. So this is how we draw this thing from scratch. So normally, again, starts off with no data. We pull the data in, we determine how it's going to lay out, we color things the way we want to color them, and then in the lower right-hand side, we can determine what color they will be in the event that they go to higher metrics. So in this case, if this says online, it's green. If it says it's degraded, it's gold. Offline is red, and so on down the line. So that, again, at a glance, if you're the server administrator, you come here and look at this, you know instantly what's red and what's not and whether that matters. I mean, I wish I could make you feel the pain that went into carefully constructing every one of these so that the metrics lay out in the way that they do at a glance. The important part that you do need to know is that nobody else in the world that we know of has this kind of power at their disposal in looking at their server. And yes, there's lots of metric data out there that'll have CPU load or memory load or CPU temp. I do not believe that there are any that looks at your ZFS statistics and in all of your drives, quite frankly. This has your data pool, this has your operating system drive RAID system, your data pool RAID system, your backup drive. Gives you so much data at a glance. What temperature are they running? What kind of drives are they? What RAID pool are they on? What's their condition? Are they online? And so on. There's just so much information at a glance. It's so valuable, and it is unique to the ServerMatter servers. All right, so this is beautiful, but now we need to know where do the numbers come from? Where on the server is this program pulling the actual numbers from, and how do they get there? Okay, so it all starts here. We've created a systemd service within Linux, and you can see if we look at those with an asterisk here, we see the service and we see the timer. This timer, every 5 seconds. Now, by the way, we used to have it every 1 second. That's been changed. It's now every 5 seconds. It checks the status of these files and to see what metric needs to be created. Now, let's go ahead and take a look at what gets run. This is the service that gets run every 5 seconds. And we see it calls a script called run all scripts. So let's go ahead and take a look at that. Okay, run all scripts is basically, I'm not going to get into all the minutiae of this and put people to sleep. The job of this script is to find every script within this genstats directory that starts with the term gen for generate and run it. So every 5 seconds, that run all scripts is going to run every script in this directory that starts with the name gen. Now, if we look in one of these files, let's just take the gen bro for instance. The service runtime increments right now has set to 6. That means if we know the service runs every 5 seconds, the number of times is, if you take 5 seconds times 6, you've got 30 seconds. What we're telling the script here is we don't want you to record new statistics about this item until 30 seconds has elapsed, which means 6 visits of 5 seconds each. Because we don't want to be generating stats every 5 seconds for everything. For instance, a speed test can take 10 seconds to run. And we don't need a speed test every 5 seconds or every 10 seconds. Once every 3 minutes or so would be fine. So that's what that metric is. It says once it's number 6, then we'll go ahead and run it again. Now the timer will actually go through a process of checking whatever that value is, storing it in this file called when last run. Let's look in the when last run text file. Now you see there's a bunch of names of scripts and a number following them, and that number means it has, so we use 6 on the last script, that's number 1. That means we've already been here once, and once it's the second time, it'll up that to a 2, and the third time it'll up that to a 3. So if we see BRO1 right here, well, I'll tell you what, rather than me dig into these scripts and try to retrace all of my steps for the last month and a half of how this was constructed, I'm just going to tail the debug log, which is going to do that for me. And here you can see it said entering BRO 0 speed. It checks 6 against 5, and here it went 6 against 6. Now, as soon as it equals 6, you can see it will be generating stats, resetting value to 0 in when last run, and then it reset the speed, set to 0. Stats file was created right here, and now this is 5 seconds later, where it runs it again. It enters the file. We've detected that it's the first time that it's been back out of 6, and this is the second time it's been back out of 6, and so on down the line. And until that 6 equals 6, a stat won't be generated, and the CPU power and memory power required to generate that won't be required. Now, I purposely grepped on BRO speed here so that we could isolate that particular script, but if I take that out, you can see that there's constantly something happening, looking at different scripts, generate net metrics, lots of different metrics being looked at every 5 seconds, and it's going to leave, or it's going to say, you've now been back here enough times, we're going to go ahead and generate the statistics. Okay, so where do the statistics live? There is a file called stats in Web Vitals. These are the dormant files that contain the JSON data that we'll be looking at with our different programs. So this one right here, for instance, gen bro speed out, which was created at 1932, which is right now. If we look at that, we can see this. That's the bridge speed. That's the speed of our network adapter. It is 1 gigabyte, so we know that that's all right. Download out, 471 megabytes per second is what that's running at right now. And here we look at some of the services. We see MariaDB, we see Nginx, which we talked about earlier, PHP, and so on down the line, and it gives us the status, whether it's active or not. So each one of these are looked at, and so this is where all the metrics are stored that those scripts have created. Now, what's next in the chain? So first up is Zabbix. Zabbix is a very detailed, intricate, granular program that allows us to look at all of these different metrics, and we haven't even begun to scratch the surface on what we're going to do with these metrics as far as alerts and that kind of stuff. That's going to come in the future. But right now, you can see CPU load, 7.9%, CPU takers, and it gives a list of each individual taker and what percent of the CPU. This is a lot of information, and it's all accurate information, but the average person is never going to get their head around all this stuff. It's going to drive them crazy looking at that, and that's where Grafana comes in. Grafana sources a lot of its data from Zabbix, and it also sources other data directly from the script data, the data that we just showed you that's sitting on the server, those files containing the output. It also sources it from there. Zabbix sources all of its data from these files. Everything it gets from these files. Another way of using Zabbix would have been for Zabbix to create its own scripts. You actually create scripts within Zabbix, or tell Zabbix to work out what these numbers are. And what I have found is if we put the load on Zabbix, we end up with backed up queues where it's waiting for one thing to finish before it can get the metric on something else. And we had a big problem with that, and a lot of queues stacked up. And if the queues stack up, the readings that you're seeing over here will in fact be wrong, because we have found that queues have stacked up for 20 minutes and you're seeing 20-minute-old data here. We can't have that. So I ended up creating the bash script solution that you saw earlier, that with the system service that runs every 5 seconds and then determines whether the script should be run, and then creates the data and just stores it in a file. So all Zabbix has got to do is go and pick it up. And so now if we take a look at administration in queues and the queue overview, we see this beautiful thing where we have no stack up, everything's a 0. That means every service that we're requesting for it to check is resulting in real-time data and no backup whatsoever. And speaking of real-time data, let's talk about how that's done a little bit. In Zabbix, we have 2 templates that we've created. One is the ServerMatter template. The other one is the ServerMatter net template. In the net template, we've isolated those things that are network related or internet speed related. The other things are all in the first template. We've got 5 discovery rules within that, and I'm not going to go into all the minutiae, but within these rules, you have prototypes in some cases, and in fact, in many cases. This is our first experiment with triggering, which ultimately will be able to trigger emails to send us information on this if it goes higher or lower than a parameter that we're looking for. As it is during the recording of this video, we have our own internal bash script which does a lot of the measuring of these things and sends us emails, so we're covered right now. But in the future, we want all those alerts to move into the Zabbix environment, which gives us a more complete picture. And so these 2 templates are attached to our host, which in this case is the compumatter.biz server, and we don't use any other Zabbix template or metric. We only use the things that we've created, so all other things are ignored. We could delete every single other one of these. They would have no effect on our server. In fact, we probably will be deleting every single one of these as we move forward because we don't need them. Okay, and that brings us all the way back to our dashboard in Grafana, which let's just show you a little bit about what that's doing. It's going to be important to know. Let's look at our drive statistics. If we edit that panel and look right here, we're using a data source called Infinity. That is a plugin within Grafana, which reads directly from JSON files. And then we provided the actual name of the file that it should be reading. In this case, it's GenDrives Grafana Merge Health. Okay, if we come over here and look for GenDrive, that's a long one, Grafana Merge Health, we see there's a ton of data in there on all our drives. So it's not reading directly from Zabbix in this case, it's reading from the file that we generated. But that particular file, we also generate Zabbix data and this data at the same time. We don't always do that. It just depends on how complex it is and how the data is best read into Grafana. But there are some of these that read directly from Zabbix. Let's take a look at the CPU load. If we edit that, that's also using the Infinity, so it's reading directly from a JSON file. Maybe this guy. Yeah, so this is our memory readings. Our memory readings, this is a time series, so over time it gives us a picture of who's using more memory. This, in fact, is using the Zabbix plugin, and so it's reading the data directly from Zabbix. Zabbix is pulling it from one of those files. And the difference between Grafana and Zabbix is Grafana is not capable of saving any data over time. It literally only gives you whatever is currently available. Zabbix does save data over time. And so if we use a Zabbix plugin, Grafana is able to see that data over time. But otherwise, we would have no way to have that functionality within Grafana. If you use a JSON script for Grafana, it's just reporting that data back in real time. So I think, let's talk about, let's talk about, we put all that time into creating everything on the CompuMatter server for Zabbix and everything on the CompuMatter server for Grafana. But now we need to get what we've created to our clients' servers. So let's talk about that process. Okay, we are in a program called Ansible, but before we get there, let's talk about this script right here. Import from CompuMatter. And what this script does, it's a simple bash script. You can put it on any server as long as it can see the IP address that we've described here and the port that we've set up here. And you have, in this case, the SSL, your SSH certs set up so that it has the credibility to log into the server. We've done all that in advance. And then we've created this bash script, which when run, will actually go to the CompuMatter server using this information, and it will pull out all the Zabbix data and all the Grafana data that we've constructed, and it will store it on this Ansible server. Because the Ansible server is where we run our automated software from. Ansible is what it's the software that builds our servers. So now we can take a server that's never had this stuff on it before and install it across the internet. So this is the file that brings all that stuff down. I'm not going to get into that in detail. I just want you to know where it is. And then we run this. It's called Vitals. And when Vitals is run, it's the import. Let me be clear. The import from CompuMatter just pulls everything in, and now it's there. So, for instance, our GenStats. Let's go to Files, Web Vitals, GenStats. Okay, we've got all these scripts, these generation scripts that you saw me talk about earlier. Well, that import file went out to CompuMatter and pulled all of those gen scripts into this Ansible playbook so that they can be pumped out to other servers. And there's a lot more to this vital statistics role that's within Ansible, but that gives you an idea of how we get it here. Because we're going to make changes over time, and we're not going to want to manually put each one of those in our Ansible role. We're just going to want to pull them all down. Okay, and here's an example on this screen of we just ran that Ansible role on all of our SM servers at present, and one of them is offline. That's okay. It's a cloud experiment server. We've run the playbook. If I take myself out for a moment, you can see we've limited it to the vital statistics. We've said send it to every SM server, and just that quickly, everything that we've created over the last month and a half got sent to every one of our customers. And we're going to show you an example of that. All right, so to start with, this is the CompuMatter server. We will now move on down the line. This is the Welch Brothers server. This is the Anacortes Marine Group server. And by the way, they are the ones that have 4 virtual machines using a lot of memory, so they're pushing up a little higher. We have Underwood architecture, and we have ServerMatter, which is 91% memory because they're running with 32 gigs, and it supports a terabyte, so they are actually a candidate for a memory upgrade. Not in a dangerous situation. 91%. It's red to let us know that, but frankly, if a sustained memory usage of sustained memory usage of over 90%, my advice would be for them to upgrade, so that's what we're going to do. And that's it. It's a long video. It's a very detailed process from start to finish of how all this works. But from this point forward, at a glance, our server administrators are going to have a very big arrow in their quiver at determining what's wrong if something's wrong. Thanks very much for watching. Bye-bye.